What's the sense of this? Running up to beat, right? Okay? Now you're ready to go, right? You're ready for the homework.
Yeah. You're ready to grade it.
Closer. Keep in mind, you can work on this over the weekend. We can come back and we can look at them on Tuesday. What questions you have? Okay?
That goes at 5:30,
Yeah, no.
9 o'clock on Sunday.
Yeah, that's exactly what I'm.
Great, let's Cal, I need that.
What's that? You're gonna work on it from 5:30 to 9 o'clock on Sunday?
Yeah.
Must be a lot of work.
We'll take a break about halfway through there.
Something like that. So we've got 20 minutes.
Do you have problems for us?
Did we solve
I
everything?
will post some problems for you. Yeah, this is done.
Oh.
You're done. What, do you have some additional unknowns?
No.
I just don't. I just felt like I didn't know. I didn't have a sense of closure. I don't know.
I got 4 pages going over here and I'm just make sure we got it all.
So what I would say is, once you define everything on here, once you know the forces of all your members, you're done. That is your closure. Everything's solved for. Okay, so I will post you a couple of problems for these. I'm just gonna draw them out by hand and throw them up on there. Do you want to look at another example like this, or vertically loaded with the rest of the time, or can we start talking about shear?
I think it would be easier for the homework if we broke it down and did maybe part of it, and then came back and to see if we were doing it right, because it's kind of pointless to keep going if you do the first part wrong. So,
Do shear, that's directly related to this?
No. Shear is a new concept.
So we
I'm not
can
ready
totally
for
screw
that.
this up and then do fine on shear.
Okay, so you want to do another example? I'm fine with doing another example. It's, okay.
Just out of, you wanna do like the vertical ones or? I think
Should we-
Those ones are easier, aren't they?
What's that?
Aren't they, those are the easy ones.
vertical force.
Yeah,
Having a vertical force?
yeah.
I would agree with you on that. I mean, from an intuitively seeing what's going on, I think it makes more sense, right? Because with a vertically applied force,
Yeah.
everything's getting pushed down. Once we start applying horizontal forces, now we're trying to rotate the truss, okay? And so that's gonna start throwing things off. So it's up to you. Do you wanna do another horizontal or do you wanna look at vertical?
I think I'm good. I know I'm good on vertical,
Yeah.
Okay, so do another
but
horizontal?
I think so,
Okay.
cause I can't tell you shit about it. I have a hard time even copying the notes down.
And everybody's good with this? If it goes away.
Yeah, do fun, do it.
Do you have the sufficient amount of information written down that is represented on the board?
See some good.
Is that all you look at? Are you supposed to know anything?
So let's look at the case. Let's get back to an equilateral truss. But we'll keep a horizontal load, okay? So that's
I'm
5 feet.
volunteered for this.
So that guy will be 5 feet. Just do 7 feet here. Okay. So what do we have to determine first?
The
Your zero.
moment around the E point, right?
We want to set up our equilibrium conditions, right?
Yes.
Okay? What do we have in the X direction?
The 600 pound.
We have
Oh, I
a
see.
600-pound force
Yeah.
and RAX. So what do we know about RAX?
It's negative
It's negative 600.
Negative 600 pounds is drawn, right?
or we're assuming it's negative 600.
Well, you already know the direction of this.
What about in the Y direction?
RAY.
RAY and RC. Okay, can we solve those?
No, not right now.
Not currently, right? Two unknowns, one equation,
We're gonna have to solve for a moment.
okay? What do we want to look at?
Well, we could solve for RC.
You want to solve for RC, so you want to take the analysis about A?
Yeah, cool.
Okay. So what forces are going to try and rotate point A? Is this X component of the reaction going to impact? Is it trying to rotate at all?
No,
Why not?
because isn't that the stagnant?
It's pushing right through that point, right?
Yeah.
So it's trying to push the point, but it's not going to be able to rotate it at all, right? What about this reaction?
Yes. No, because it's directly, it just pushes,
Traveling
it do
through
the same thing.
Yep,
It
it's
push
trying
it
to
up.
push the point up, but it's not trying to rotate, okay? So what forces are trying to rotate?
It's the 600 pounds.
600 pounds. What is its distance?
10 feet. Oh, no,
Careful.
7 feet.
if we're
Okay.
solving for what? If we're solving for
We're
A,
looking about A.
there'd be zero, there wouldn't be,
7 feet away from me.
oh,
Why is it 7 feet away?
Because
Oh,
it's
straight
the,
up.
the
it's
length.
straight up
We're
above.
moving it along, right? And its distance is the 7 feet, okay?
Okay, yep.
So then you would have,
And then is it trying to rotate in this direction?
Mhm.
Or is it trying to rotate in this direction? It's trying to rotate
Yeah.
clockwise, right? Okay, so it has a positive sense. What about RC?
so the RC.
RC would have, are you asking if it would have a positive sense?
Sure.
Yeah, it would.
Is it going to try and rotate A this way? Is it going to try and rotate A this way?
420.
RC's gonna, well, in that case, I mean, is it trying to,
It's going to try and rotate counterclockwise, right? It's gonna push, and it's gonna push this way,
oh
about
yeah,
A.
because that's pushing up,
We're
right?
looking about A,
That's pushing up, yeah.
okay?
So mine,
So that's gonna be minus, how far away is it?
10 feet.
10 feet away.
It's 420.
Okay? So what does RC equal? Whoops, what to say? It's gotta equal 0, right?
420.
So RC equals 420 pounds,
So RAY would be the negative.
so RAY equals minus 420 pounds?
Yep.
Okay. Has anyone noticed a pattern with the reactions and the orientation of the force being applied?
it goes in a circle, is that what are you talking about?
When we apply a force in this direction, which direction does RC ultimately end up acting?
Negative,
Positive.
right?
RC
Pushing
exerts
over-
this way, right?
Pushing over the hill kind of thing, you know.
Okay. How does the reaction at A work?
Push.
This is negative, so how is it actually drawn? It's actually holding it down, right? Because remember, This force is not only trying to push the truss this way, it's trying to rotate and overturn everything. Okay, so it's trying to pull up at this point. So what does that mean if we have a force traveling in this direction?
You need a
RC would be done.
You just flip them, right? RC has to hold the truss down. RA has to then prevent from being crushed. Does that make sense to everybody? Kind of? Sort of, maybe? Okay.
I'm good on the first part. That was
Everything
the
else,
homework,
every-
man.
everything
Hey,
else
that's
is,
cool.
everything else is just doing the same thing, just breaking it down to joints.
Oh.
So which joint do you want to look at?
Well, I mean, let's just keep going with C, you know, because I'm sure
Look at
that's how
C.
we're all gonna do it at home, is the same
Okay.
kind of process.
So at C, what do we have?
RC.
RC, you have member BC, and we have member AC. Okay?
So the angle,
We want the.
You want to determine angle C?
yeah. So we know it's 5 feet and 7 feet.
Mm-hmm.
So what is it? That would be the inverse tangent.
Mhm.
7/5.
Mhm.
Holy shit, I got it.
54 degrees again. Okay?
I didn't know that.
So a little 10-minute reminder.
Okay.
What do you want to determine next?
Wait a minute, why did you do it on the inside this time? Because it doesn't matter. Or you,
Do what,
you drew like the.
do what on the inside?
Oh,
Oh,
he's the
Online.
fourth.
my member forces? Does it
Yeah.
matter where they are?
No,
That was
trying
funny.
to,
Wait a
and
minute.
Rick does,
Just making sure you're still awake, John.
I am. We,
Barely breathes.
So what do you want to solve for? What would be the easiest to solve for at this point?
BCY.
Why is BCY going to be the easiest to solve for?
we already got one.
We already know what RC equals,
Oh, so it's gonna be just.
Negative.
and those are the only forces in the Y direction, right?
Yes.
And we know that if we're going to have equilibrium at the joint, it's only going to be the case if all our forces sum to 0. Okay?
So since RC is 420, BC.
So BCY is 420 pounds as well. Okay?
Now,
What would have come out of this had I, instead of having BC coming down into the joint, if I had BC going out of the joint,
No, it'd just be negative.
it'd be negative 420, right? Okay, good. Good.
that's all right.
What's odd?
No, I said that's how I drew it.
Oh,
So I
gotcha.
got the negative.
Gotcha.
It don't matter.
Yeah, it doesn't matter,
doesn't
right?
matter, no.
If we get a negative value, we just flip the direction, okay? What do you want to determine next?
BCX.
BCX? What does BCX equal, Kyle?
Well, it would be
So if we know.
tangent 54.
Okay? tangent of 54 degrees equals
420 over BCX.
420 pounds over BCX,
Yep.
correct? So BCX equals 420 pounds divided by tangent of 54. Okay,
It's 305.
that's how much?
305.
Isn't this less than 1?
What is it, 420 divided by?
1.37.
Oh, it is, okay. So 385?
300. 305.
305.
Yeah.
Okay. So now we know BCX. What do you want to determine next?
So we have
So what's left is
BCX and BCY.
BC.
BC.
You want to determine BC? What is
which
BC?
We can do Pythagorean.
It gets back to what Kyle said on the last problem, right? Now we can take one of two paths, right? BC would equal either the square root of the sum of BCX squared and BCY squared,
519.
519. Okay?
Or you could do it with the sign.
Or we could use trig, right? Okay? So we know BC. And BC generated is a positive number, okay? So the assumed sense that it's compressing down is correct. What about AC? How can we determine AC? Don't the sum of all our forces in the x direction need to
X
equal
is
0?
So if BC X is 305, it would be negative
Oops,
305.
sorry. So AC equals negative 305 pounds,
Okay,
right?
I agree.
And I made the consistently wrong assumption from the last problem where we applied the force in that direction, right? Or when I assumed that we're compressing on that member there, we're not. We actually have tension. Okay. Okay. So we know AC. We know BC. We already knew that reaction. Okay. So we're finished with that joint.
Okay.
We also know that AC now is 305 pounds. Okay? And we know
See any more?
BC is 519.
Motion done for the BC.
Okay?
On A.
Should we look at B?
He know
Or
that.
do you want to look at A? B?
Still have that ribbon.
Huh? That's like,
I didn't even know. I didn't even refill. It's class depleted it.
rough.
Okay? What is it that we need to know?
BC minus AB. So we need, yeah.
What do we wanna solve for first?
Well, we know, we can do ABX, can't we?
Do ABX? So you wanna say we need to have that all our forces in the X direction equal 0, right?
Yeah,
So it would be 600 pounds plus ABX minus BCX, right?
BCX
What was BCX?
was, BCX was,
519, thank you.
I thought BC
Or
was 590, it was
307.
305,
Or
wasn't it?
305, yeah.
305?
Yeah.
So what does ABX equal?
295?
295, right? And it actually, if we draw it in this direction, it actually equals negative 295, right?
If it's going up,
Yep.
yeah.
Yep. Okay. What else?
So now we got that, we can do,
Now we can determine member AB, right?
yeah,
I mean, we can also determine the Y component of member AB, but do we need to determine the Y component of member AB?
no,
Is it
We're
adding
looking
any
for-
value to us solving the problem at this point?
no, we're trying to solve for AB.
We're just doing more work, right? Do you guys like doing more work than is necessary? Good. Glad to hear it. So what does AB equal?
So it would be the sign,
Sine of what?
well, we don't have any angles, so.
Don't have any angles. Can we come up with an angle?
Yeah. Wouldn't it just be 45, because it's an equilateral?
It's equilateral.
Careful.
That's,
3, 4, 5 pound.
No,
but you know.
These angles will be equal, right?
yeah, but it's not, it's not, it would have
It's not
to be
going to
5
be,
feet the
this
other
would
way.
have to be, well,
That would have to be 5 feet.
So it's
Yes.
54.
so it's gonna be 54 degrees, right? Because we have the same dimensions here, right? This is also 5 feet also.
Would that have to be 10 feet though, to make it equilateral? All the way around?
This would need to be equal to 5 feet if we wanted these to be equilateral.
Yeah.
Oh,
But since they're equilateral over there, we already got that C.
Yep. We know that this angle is 54 degrees. Because our dimensions are the same. Okay? Does everybody see that? Do you see why that's the case? Right? This length is the same as this length,
Mm-hmm.
right? We aren't changing that height, and we've already calculated what that angle is, okay? So AB equals ABX over,
That'd be so. Sine of 54.
do we want to use sine?
Oh, no.
We want to use,
Cosine.
we want to use cosine, right? Because when we're looking at this angle, ABX is your adjacent leg, okay?
So. 502.
502 pounds? Yep, very good point, Kyle, that if this member is drawn compressing on joint B, this value will come out as a negative 502 pounds, okay? Done. Marshall, did you get closure? All right. Now, are you ready for homework?
Let's.
Can we get back to you at a later time?
Absolutely.
Answer key for the homework?
Yeah, that was something I was gonna ask you. If you could just give us like the value that we're supposed, like the end value we're supposed to come up with, nothing else, just so like when we're done, we know
Yeah, yeah.
if we freaking got it right.
Yep.
That's how our math class.
Instead of just
Didn't
shooting in
I-
the dark,
Should
you
give us
know?
the answers.
Yeah. Did I not post, I scanned in an answer key. Did
No,
I
no,
not
no,
post it?
I mean like, just
Are
some,
you
just some
serious?
straight values so we can check where we're going.
Yeah,
Oh, you have, oh,
Yep.
maybe, oh,
yeah.
maybe
Check
I
for
was-
homework 1. I haven't looked at homework 2 yet. I'm gonna grade that tomorrow.
Yeah. Oh,
Uh,
you posted it after we turned it in?
After,
yeah,
No, okay.
he means during.
So I know if I'm doing it right. Cause like if,
well, no, I'm not gonna put the answers up while you're working on the homework.
well, no, the final, or I guess for these it doesn't work.
You'll have access to an answer key. Give me 1 second. After it's due.
After
Yep.
it's due.
There's so much work, so.
Yeah, I mean,
The final answer, you know.
Yeah,
Yeah.
absolutely.
cause it's basically a shot in the dark until you get
Yeah.
it graded.
You guys so good.
Not asking you to do the homework for me, I just want to know if it's do it.
Okay.
What? You?